You've been there, right? You're about to grab those concert tickets, the last ones, and then the site just dies. So frustrating. Well, today we're going to dig into exactly why that happens. Why do our favorite apps and websites sometimes just crumble when they get popular? Let's get into it.
Oh yeah, that feeling, the spinning wheel of death, you just hammering that refresh button hoping for a miracle. It's more than just annoying though. It's actually a sign that a system has been pushed way past its limits. So what are those limits and what makes them break? Okay, to really get a handle on this, you have to understand the sheer scale we're dealing with. I mean, this isn't just a little bit of growth. It was a digital big bang. We're talking about going from a few million internet users to over 3 billion in just 20 years. Think about it like this. You build a little 2-lane road for a small town, and then bam, overnight it needs to be a super highway for an entire continent. That's the kind of insane pressure these systems are under.
So when that pressure gets to be too much, a system hits its breaking point. And that brings us to this key idea: scalability. You hear this word thrown around all the time in tech, right? But what does it actually mean? Let's, break it down.
Now, on the surface, it sounds pretty simple, but in reality, it's a massive challenge. See, a truly scalable system doesn't just not crash, it has to keep performing well. It's kind of like a concert venue that can magically add more seats and open up new entrances as the crowd gets bigger, making sure everyone has a good time, not just the first few people who manage to get in the door.
Okay, so that begs the question, right? If the internet has grown so much, how come the whole thing hasn't just collapsed? Well, the answer is in its design, which is actually brilliant and surprisingly simple. It was literally built to scale right from the get-go.
So the internet's secret sauce for scaling really comes down to 3 things. First, it's open. Anyone can connect and build on it. Second, it has a nearly limitless supply of addresses thanks to something called IPv6. Just think of it like having an infinite number of street addresses for the whole planet. We're never going to run out of room. And finally, it's dynamic. If one path gets clogged up with traffic, the internet is smart enough to just find a different route. It's like a Waze or Google Maps, but for our data.
But here's the thing. The internet isn't just some magical cloud, right? It's made of actual physical stuff. Cables, routers, all that. And that means it has physical limits. You've definitely noticed this when everyone in your house is trying to stream something at once and it all grinds to a halt. Yep, that's a bottleneck. Your home router, the Wi-Fi at your favorite coffee shop, they can all get totally overwhelmed. And these are the weak links in the chain.
All right, so the internet itself, the foundation, is built to scale. But what about the apps and websites we actually use every day? Well, that's where things get a lot trickier. Let's dive into a perfect real-world example, Khan Academy, and what happened when suddenly the entire world needed them at once. 250%. No, that is not a typo. When the pandemic hit and schools shut down, Khan Academy servers just got slammed with a tidal wave of new users. It was this sudden, completely unprecedented test of how well their system could actually scale.
And this graph, wow, it tells the whole story. You see those little dips on the weekends? Totally normal. But then look at what happens on that Monday. The demand doesn't just go up a little bit, it absolutely explodes. This, right here, is what a system under siege looks like. And this is where the cracks started to appear. Their system for sending out assignment notifications, the thing that tells students they have homework, it just got totally overwhelmed. This graph shows a massive backlog of those notifications just piling up, higher and higher. And look, for a student who's waiting on that assignment, even a delay of a few minutes feels like forever. It's a big deal. But check this out. This is the amazing part. See what happens right around 9:30 in the morning? Poof, the backlog is just gone. Their engineers, who must have been under incredible pressure, were able to scale the system on the fly. They threw more capacity at the problem, and the system caught up almost instantly. Now that, my friends, is a masterclass in how to do scalability right.
So Khan Academy is a great story of successful scaling under fire. But what happens when a launch is so ridiculously massive, so unexpectedly huge, that it just shatters every possible expectation? Well, for that story, we have to talk about the legendary, chaotic launch of Pokémon Go.
Okay, so before any big launch, engineers do this thing called load testing. They basically create a fake digital mob, a stampede of users, to see if their system will buckle under the pressure. And the Pokémon Go team? They thought they were prepared. They tested their system for 5 times their most optimistic pie-in-the-sky prediction, and it passed with flying colors. They really thought they were ready for anything.
They were so wrong. On launch day, the traffic wasn't 5 times what they expected.
It was 50 times their estimate. 50. It was fueled by this perfect storm of a massive global brand and this brand new augmented reality gameplay. Just look at this chart. See the orange and red lines way down at the bottom? Those were their predictions. And that green line shooting up into the stratosphere? Yeah, that was reality. They had unleashed a monster, and their servers were literally on fire.
So for millions and millions of people who were so excited to play, this screen was their entire launch day experience. All that hype, all that excitement, just to be met with a server error. This is exactly what happens when a system just cannot scale fast enough to meet an insane level of demand.
And behind the scenes, the company was in total crisis mode. You had the engineers in an absolute race against time, trying to basically rebuild the whole thing while it was flying. At the same time, the PR team was trying to calm down a global firestorm of angry, frustrated players. It was a battle on two fronts, for sure.
So we've looked at a few different stories here, right? A system designed from the ground up to scale, one that scaled brilliantly under huge pressure, and one that, well, famously buckled. So what's the big takeaway from all this?
I think the most important thing to remember is that scalability isn't just a simple yes or no checkbox. It's a whole spectrum. You could say Khan Academy was prepared for a big storm, but Pokemon Go got hit by a Category 5 hurricane they never saw coming. So the real question isn't, is it scalable? The question is, how scalable is it? Because in today's world, where an app can go from zero to a global phenomenon overnight, building for scale isn't just a nice-to-have, it's an absolute necessity. It really is the difference between building a sandcastle that gets washed away by the first wave and building a skyscraper that's designed to withstand anything. One is temporary, the other is built to last.
So we've talked a lot about hardware and user demand. But what else do you think affects scalability? Could it be the way the code itself is written? Or maybe the type of data the system is dealing with? Or could it even be us, our own unpredictable behavior as users? Something to think about. The next time an app crashes on you, you'll know it's not just some random bit of bad luck. It's actually a super fascinating puzzle of scale. Thanks so much for joining me.